In example 2, we have an example pretty similar to the last two in this video set. And we've got a graph here of a function f of x, and we're going to use that to answer each question. If we look at a, b, and c, those are different than d, e, f, and g. They're really entirely different problems. A, B, and C deal with just function evaluation. What's the output when the input is whatever's listed? D, E, F, and G, we're more concerned with the limit as x is approaching a number, and we're concerned with what value we're approaching or getting close to, but not exactly equal to. So let's work with the other definition here for part A, B, and C, or the other type of thinking. F at 0. What is f at 0? Well, when x is 0, y is 0. So we can list that here. What about part B? F at 2. Looks like there's a vertical asymptote right here at 2, and neither branch of that graph will hit 2. So we would say that f at 2 is undefined. We're not really sure what that is. You can't get it from the graph. There is no y value when x is 2. How about f at 3? Well, f at 3 is right here, and it looks like that y value is 0, just like f at 0. Let's run through a few of the limit questions now. We'll take a look at the limit as x approaches -1. There's no plus or minus sign in that exponent or superscript position, so this is going to be a two-sided limit. Well, if we approach -1 from the left, the graph just continues up forever, or to positive infinity. If we approach -1 from the right side, the graph just continues down, or to negative infinity. Those values are definitely not the same. Well, they're just concepts, I guess, not actual numbers. But anyway, the limit from the left and the right is definitely not the same when x is approaching -1. So we would write DNE, standing for does not exist. That two-sided limit as x approaches -1 of the function f does not exist. How about the other part here, E, the limit as x approaches 0? Well, we're going to do the same thing in checking that the limit from the left has to be the same as the limit from the right. So I'm going to be a point on the graph, and I'm going to be approaching or getting close to an x value of 0. And then if we're a point on the graph approaching or getting close to an x value of 0, it looks like that y value is approaching or getting close to the same thing from the left and the right, which is 0. So this two-sided limit does exist, and that two-sided limit is equal to 0. For the next part, F, we're going to look at the limit as x approaches 2 from the right. Well, as x approaches 2 from the right, if I'm any point on the graph and I'm trying to get closer to an x value of 2, my y values just continue down forever. The closer I get to 2, the further negative I get. And so I'm going to write negative infinity here, or if you really want, you can put DNE, because negative infinity is not really a number, it's just a concept. So there is no limit. Let's take a look at G, and G is called an infinite limit. It's called an infinite limit because it's as x approaches infinity. And if x approached negative infinity, that would also be an infinite limit. Let's see if there's an actual value this one approaches, or maybe not. So here I am, I'm a point on the graph, and I'm going to continue all the way to the right. And it looks like we have this horizontal asymptote here. So as we make x bigger and bigger and bigger, or more and more positive, the y value of 1 is what we are approaching here. Now, we'll never actually get there. We'll just get closer and closer and closer to it. But the limit doesn't care about what the function actually exists at. It's what we're approaching or getting close to, which totally is 1 for this one.